All right, guys. So, now that we've talked about blood in quite some detail, blood typing, the AB, ABO, what agglutinogens or antigens are versus antibodies, who can donate blood to who, and whatever the case is, this is a website that I showed you in the beginning of the lecture series videos, and it comes from the redcrossblood.org website. All right, redcrossblood.org website, and it's under kind of their blood link or their blood donating link. And we talked about how parent lineage basically determines what your blood type is going to be as a child, and I showed you this reference chart down here at the very bottom. But there's actually other pieces that are on this same website that are going to be very important as well, that I think will get the point across visually, not just lecture. Okay, so here we have a test tube, and it's filled with blood. And the blood has been spun down, centrifuged, and we've got the red blood cells toward the bottom, and we got the plasma that sits on top. And this is a group A red blood cell. So that's why you see A that's down here. So these red blood cells have the A protein, the A antigen, the A agglutinogen. And then in the plasma, these are kind of, what does it look out for? They've got to have some fighters. So A hates B, right? Again, it's like politics. So if B comes into the picture, A has got to be ready to put up a fight and go out and kill all of the B blood cells that come into the picture. So that's why B is in the plasma. These are antibodies that's in the plasma. So blood type A has A protein, A antigens, A agglutinogens, but they make B antibodies. Antibody means go against, right? So they need to go against B. So in your blood sample, when we spin them down, the B antibody will be located in the plasma. So group B people would be the same thing, right? B red blood cells, they hate A, so their antibodies have to be A in the plasma. That way, those antibodies will go out and kill the A blood cells, because that's how they're built. They are built to recognize A and to kill A. So hence, antibody A. That is what's in the plasma. Group AB, well, their plasma actually doesn't have anything at all with it. So the red blood cells have the A and the B proteins. And their plasma, well, they're okay with everything. So A's present, B's present. If you're an AB donor, that's great. You'll take it. If you're an A only, that's great. You'll take it. If you're a B only, you're great. That takes it. Again, we're leaving out the rhesus. We're leaving out the positive and the negatives here. So the plasma doesn't have any antibodies at all, because it's not built to fight anything that comes into the picture in terms of A or B. And then group O people, like me, my red blood cells have no protein on them at all, which means if A comes into the picture, I've got to fight it. If B comes into the picture, I have to fight it. If AB comes into the picture, I have to fight it. So my plasma will actually hold A antibodies and B antibodies, because my system cannot take either or a combination of them both. So I think that does a very good job visually to make the distinction between the antigens protein side and then the antibody side of the house, and kind of how it's located. Here on the website, you also see some donor bags. And again, if you are a O recipient, so if you are a O blood carrier like me, then I'm going to click that, and what I'll see is that this O can donate to another O person. It can donate to an A carrier. It can donate to a B carrier. And it can also donate to an AB carrier, because I don't have any protein on the surface of my red blood cells. So I can give blood to basically whoever I need to give it to, if I don't really take into consideration the rhesus, the positive or the negative, the RH. Right? If you are a B donor, though, well, B blood can only be given to other B carriers, and B blood can only be given to AB carriers. That's it, no more. I can't put B into a person with A, because they will kill in jail, and I can't put B into a person with no protein at all because, again, it sees it as a virus or some kind of threat. It invades an invader, and it will kill it and gel it up. All right, so just how donor association is going to be handled. And then finally, here we get another depiction of red blood cells. And with these red blood cells, you can click on a blood type, and it will show you basically the percentage of people that carry that type of blood. So, for instance, I am O positive. If you look at the rhesus factor, or Rh, I am Rh positive. So the O carrier is going to be the majority of the people in the world, or in the United States at least, right? Sorry, it's the United States. So quite a bit across the ethnicity kind of thresholds. It's going to be a large majority of every single person in the United States. If you take a look at the O negative people, watch what happens to the percentage. It goes extremely low. So we're talking about single digits for the most part across the board if you're an O negative carrier. But the great thing about O negative people is that you literally can donate to anyone that you want to. So if a person has a Rh plus, you can still donate to them because you don't carry that trait with you, and your body would not, or their body would not recognize your blood as an invader because it's not something extra that you're bringing to the table. But that's not the lowest percentage across the board in terms of the United States. If you go to AB negative people, those that carry the A and the B trait but are negative with Rh, you're actually seeing them with 0 point digits, 0.3, 0.1, 0.2. These people are extremely rare. So they carry the A protein and the B protein, but they do not carry the Rh, AB negative. So for the most part, those are going to be your rarest of the rare, and those are your AB little gold nuggets that are out there living in the United States. Okay, if you take a look at the difference between O positive and O negative, right? We said O positive, the percentage was higher, and the negatives, they're lower. Let's take a look at the A's. So the A positive is way higher, and the A negative goes lower. If you take a look at the B's, right? The B positives, those are your percentages. And then when you go to B negative, then you'll see those percentages lower. If you go to AB positive, those are your percentages. And then when you go to the negative version, they go even lower. So what you're seeing the trend is that the majority of the people have the Rh factor compared to those that don't in every single blood type that's out there. Whether it's O, A, B, or AB, those carriers, if they're Rh positive, are going to be more common than those carriers that do not carry the Rh with them. All right? So that's kind of a breakdown. Again, this is redcrossblood.org. So go to the website, take a look at their blood section. That's where you'll find these interactive charts and graphs and some information that they like to present to you about what blood is and what blood type actually is and where it comes from and how did it get started and how did you end up with the blood type that you ended up with. All right, so just a shout out to that website and that company. Again, I think they do a very good job kind of giving you visuals of what this information means versus just my scribble that happens on a electronic computer screen. Okay, so that ends this lecture series for sure. And then with that said, the next lecture series that you're going to see deals with blood again, but it's going to be blood identification. So this is going to pick up somewhat where we left off. If we find blood on a crime scene, you know, how can we make sure that, number one, it is blood, and then number two, what do we do with it now that we can confirm the presence of it? So this is just one step in the right direction. That's all that this is. So study up, look at your notes, go and tackle that online assignment that corresponds to the lecture material, and I think that you'll do okay. So if you've got questions, again, you know how to get a hold of me. Let me know. Otherwise, we'll see you in the lab.